Welcome to 1.6 vertical asymptotes. Vertical just means up down. Okay. Review from the last lesson. Here is an example of a vertical asymptote. We can describe vertical asymptotes using limits. In this function, the right-hand limit, it's getting bigger and bigger and bigger. This is getting bigger and bigger and bigger. When it becomes infinitely large, we call this positive infinity. So one way to describe this is to say that the limit of f of x as x approaches 2 from the positive side is equal to positive infinity. Similarly, on the negative side, from the negative side, we see that's going smaller and smaller towards negative infinity. So we can describe this vertical asymptote by saying that the limit of f of x as x approaches 2 from the negative side is equal to negative infinity. Clearly they're different. We know there's a discontinuity there, and the limit at x equals 2 does not exist for f of x. Okay. One more example. Here we have a vertical asymptote at x equals 3. Some students might say, wait, x is horizontal, right? It's left-right. But x equals 3 is a vertical line, because x equals 3 means y could be anything, but x is always 3. That means the line is actually vertical. There's the graph. In this case, the right-hand limit, well, it's going higher and higher and higher towards positive infinity. So the right-hand limit is, in fact, infinity. The left-hand limit is also positive infinity because it's also going up, 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 and up, and up. So we can say that the limit as x approaches 3 from the positive side is equal to infinity. The limit as x approaches 3 from the negative side of f of x is also equal to infinity. Because of this, we can write this as the limit as x approaches 3 of f of x is equal to infinity. But be careful, we're just writing it this way. It's just a way of describing it. The limit doesn't actually exist. No such limit actually exists. Limits only exist if the right-hand limit and the left-hand limit are the same number. If they're both infinity, well, infinity is not a real number. It's not a number in the real. It's not a real number, not a number in the real system. So we say that the limit does not actually exist. We can write this. Writing this is okay. It's confusing, but we can write this. But strictly speaking, we can't. So we can write this to describe the vertical asymptote. But, the limit doesn't actually exist at that point.